Myself Nandini Kundali. I am studying in a BSc third STEM. My combination is CBZ. My assignment topic about the Kolbes reaction, Paris rearrangement reaction, and claisen rearrangement reaction and their mechanisms also. The first one is the Paris rearrangement. The phenols on treated with an acid chloride or acid anhydride forms the phenolic esters. The phenolic esters on heating with a catalyst like AlCl3. It is a base catalyst and followed by the hydrolysis result in the rearrangement to form the ortho and para acyl phenols, and this reaction is known as a Paris rearrangement reaction. You already seen in this page. Next, the Paris rearrangement is an electrophilic substitution reaction that may proceed through an inter or intramolecular rearrangement. These rearrangement mechanisms are individually discussed here. First, I will discuss about the intermolecular rearrangement. It includes the three steps. Step 1, phenolic esters form a complex with a Lewis acid AlCl3 and leads to the formation of the acyl cation. Next, steps 2. ಏನು ಮಾಡ್ತೈತೆ ಅಸಲ್ cation attack the ortho and para position of the ring to form a uranium ion which is stabilized by the resonance. You already seen in this page. Next is step 3, the product step. Step 3, removal of proton from a resonance stabilize uranium ion and hydrolysis to gives the orthohydroxy ketone. Next, intramolecular rearrangement. Next, about the claisen rearrangement reactions. Claisen rearrangement reaction is undergoes the intramolecular rearrangement. Allyl phenol ether on heating at 200 degrees Celsius, it undergoes the intramolecular rearrangement to form O-allyl phenols, and the reaction is known as the claisen rearrangement. In this reaction, the migration of allyl group occurs at the ortho position to give the product. If ortho position is free, only the ortho rearrangement occurs. However, if the both ortho position are substituted, rearrangement takes place at the para position. An interesting features of the rearrangement is that when a migration takes place at the ortho position, the gamma carbon of allyl group attaches itself to benzene nucleus. In other words, there is inversion of allylic chain. However, no such inversion of allylic chain takes place with the para migration. The final is the Kolbes reaction. When the sodium phenate is heated with a carbon dioxide at 120 degrees Celsius to 140 degrees Celsius, it undergoes the 5 to 7 atmospheric pressure, resulting in the formation of the O-hydroxybenzoic acid. It is also known as the salicylic acid. You already learnt in your PUC. This is an example for an electrophilic substitution reaction. When CO2 act as an electrophile in phenol oxide ion, the aromatic ring is strongly activated and easily undergo the electrophilic substitution at ortho position, even with a weak electrophile like a carbon dioxide. This reaction is known as a Kolbes reaction, and it is also known as a co-Schmidt reactions. Next, the mechanism of the Kolbes reaction. The electrophile get added to the phenoxide ion at ortho position. This result in the formation of an intermediate which is stabilized by the chelation and resulting in the formation of the O-hydroxybenzoic acid or salicylic acid.